if y does not equal 2xz. And at the end of the video, if I have time, I'll address why the GMAT would include this little bit of information. But for now, let's continue to the question, and we'll come back to that little bit at the end. If y doesn't equal 2xz, what is the value of this ugly expression? So as always in data sufficiency, before we look at the statements, we want to do whatever we can to simplify the question. So is there anything we can do to simplify this term? Well, you can bet a lot of test takers will lose points right here when they see this 2xz over this 2xz and cancel those guys out. Why can't we do that? Well, if you recall your fraction rules, you remember that, well, yeah, you can cancel stuff from the numerator that shows up in the denominator, but only if you're dealing with multiplication in both the numerator and denominator. If this was 2xz times yz and 2xz times y, then by all means, get rid of these and life is easier. But that is not the case here. We've got 2xz plus yz, and we've got the minus down here, so we cannot cancel these guys out, which is a shame. Although I think it's probably no mistake that the question writer sort of temptingly put this 2xz right over this 2xz because they knew they'd catch a number of test takers that way. All right, so what can we do? Well, not a whole lot. Really, the only thing that I noticed was that there is an opportunity for factoring. In the numerator, these two terms have a variable in common. There's a z over here and there's a z over here, so we can factor that out. And the term in the question then becomes, well, factoring the z out of each of these terms, the numerator becomes z times z out of the first one leaves with a 2x, z out of the second one leaves us with a y, and the denominator is the same, 2xz minus y. And I guess we've made a little bit of progress, a little bit sort of some more apparent more apparent expressions, more apparent chunks here. And maybe we can go a little bit further. For me, visually, it's a little bit easier to think about if I just rewrite it. If I take this guy outside, maybe if I say this becomes z times, and then our numerator is 2x plus y, and our denominator is 2xz minus y. And so we've simplified a little bit. Still, before we look at the statements, I want to do a little bit of thinking. Specifically, I want to think about what we would need in order to get a value for this thing. Well, I guess there's two routes that might lead to a value for this thing. One would be simply to get a value for all three of these variables. To get an exact value for x, exact value for y, exact value for z. So if we're going to get a value for each of these variables, how many equations do we need? Well, we're talking about three different variables, so to get a value for each of those, we would need three different equations. So that's one thing to keep in mind as we look at the statements. Although we also want to keep in mind that sometimes you don't need to solve for all the variables to answer the question. Maybe we don't know exact values for x, y, and z, but maybe we get enough information to plug in for some of the chunks, some of the expressions. Maybe we get enough information to get a value for 2x plus y. Maybe we get a value for 2xz minus y and a value for z, and that would do it even if we didn't know all the variables. All right, so keeping in mind both those options, let's look at the statement. Statement number 1 tells us that 2x plus y equals 3. Well, is this going to be enough information to find all three of our variables? Absolutely not, right? We've got one equation and we're looking for three variables, so definitely not going to be sufficient that way. Is this going to be enough to plug in for all the different expressions in here, to plug in for the different chunks? Well, we can plug in one chunk actually. The numerator of our inside equation here, or inside fraction here, is the same expression that shows up in number 1. We could replace our 2x plus y with 3. And is that enough to know a value? Well, absolutely not. For one thing, we don't know what this z is out here. So this is just some unknown number times this whole thing, and, well, we don't even know this whole thing. So we definitely don't know a value for the whole thing. Number one is insufficient, and that gets rid of A and D. On to statement number two. Statement number two tells us, and we're just considering this on its own now, statement number two tells us that z equals 2. Will this be sufficient? Well, now I know that this is 2 times something. I guess we can replace this z down here also. But 2 times what? We don't know. We don't know anything about the x's and the y's. The inside expression here could be just about anything. So number 2 is also insufficient. That gets rid of B. And now we are on to considering them together. Now we know everything. We know that 2x plus y equals 3, and we know that z equals 2. So considering them together, do we have enough information? Well, do we have enough equations to solve for all the variables? Still no, right? We've only got 2 equations, and there are 3 variables in the mix, so still not enough to get a value by that route. Oh, and I should mention, I've seen test takers make a little logical error in a situation like this. They might say, okay, well, we've got these 2 equations in the statements, this guy, and then we've got this other one in the question. So what's wrong with that logic? Well, the problem is, this is not an equation. Equations are only things that tell us stuff. This one tells us that 2x plus y equals 3. But this isn't telling us anything. This is just asking. I should include those question marks. This is just asking, what is the value of this expression? What is the value of this expression? So this is not an equation. So back to our considering them together. Even together, we've only got these 2 facts, these 2 equations, so we can't solve for all the variables. Well, what about plugging in for all the chunks? And now we've got a little bit to work with. I know that I can replace the z with a 2. So together we get 2 times, and I know that the numerator inside is 2x plus 3, so I can replace that with a 3. And what can I do with this denominator? Well, the denominator is 2 times, I don't know anything about that x, it's still just x, and z is a 2, it's times minus y. So I guess we've got a little bit closer, but we still don't know a value. We still don't know anything about what x equals and what y equals, and we don't know what, I guess this becomes 4x minus y. We don't know what 4x minus y is. And it's important to note that we don't know values of x and y. You might say, well, maybe we could get that from up here, but we certainly can't. There are, I guess, infinite different solutions to this equation. There are infinite different possibilities for the values of x and y, so infinite different possibilities for the value of this expression, so infinite different answers to our question. So even when we consider them together, we cannot answer this, so we click E. And I guess we went through these steps, we sort of broke these steps down slowly, but this logic, by test day, this will be pretty quick. By test day, we say, okay, we've got this ugly expression, but we can factor and simplify, and now I need either 3 equations, so I can solve for all the variables, or enough to plug in the chunks. Statement number 1, that's only 1 equation. That's not going to be enough to solve for all the variables, and it's only 1 of our chunks, so there's all kinds of missing information, insufficient. Statement number 2, that's just 1 equation. That's not enough to solve for everything. And we don't have anything to plug in for the chunks either, insufficient. Even together, we don't have enough equations, and we never get enough to plug in for this bottom chunk here, so even together we have insufficient, so we click E. And there was something else. Oh, at the beginning of the video, I said that I would address why the GMAT included this little bit of information. So we actually didn't really use that. So why did they put that there? Well, the reason actually isn't very exciting. The reason they put that there is Well, it's actually more of a legal reason than anything else. What is the number you're not allowed to divide by? You're not allowed to divide by 0, right? Dividing by 0 ends up in weird scenarios. It ends up as undefined. So the GMAT will always make sure we're not in a situation where we might be dividing by 0. And here, we've got this expression in the question, and there's all these variables in this fraction, and they want to make sure that we don't end up dividing by 0, or they want to make sure that some test taker isn't sitting here saying, well, this question isn't quite valid because, the possibility of dividing by 0 is left open, and that leads to weird, undefined territory, so it's a bad question. So that's the only reason I put that here, to make sure we don't divide by 0, because if y did equal 2xz, well, then this would be something minus itself. And we'd have a 0 down here, and some test takers would complain, and the GMAT would be in trouble. So that's the only reason for this thing. All right, but the big takeaways here were simplify the expression first, and as you're going to the statements, you're considering how many equations you need and whether you have enough to plug in for the chunks. All right, I've talked for way too long about this video, about this question, so I'll see you in another video.